So we're recording. Don't say anything you wouldn't say in front of Santa Claus. All right, you don't want to cold for Christmas, I guess. All right, guys. So we're going to go through that last example of least squares stuff. All right, and let me bring that up really quickly so that way you guys can kind of see what we're doing and kind of remind yourselves as to all the fun stuff that we have. All right, so let me blow this up a little bit so you all can see it. Oh, maybe too much. Okay. So remember, guys, what we did was we found the equation of the line that passes through the majority of the data. That's the least squares line, right? And what we're going to do today is we're going to kind of do everything that we did last class. So if you guys remember last time, what we did was we found the equation of the line, okay? We used both our calculator and a formula. We were able to do some extrapolations and some interpolations. And then finally, we were able to compute the residuals and construct the residual plot to help us find any suspect observations, okay, or any data that we believe may be an outlier from the rest, okay? And that's everything that you're going to have to do on quiz number 3. It's also the last question of your exam. It's also what we're going to be doing today, okay? All right, so let's get to it, okay, with this example, okay? So the data below shows the relationship between height and weight of 4 NFL quarterbacks, okay? And as we generally know, the taller you are, the more mass you have, so the more you generally weigh. All right, so not surprisingly, there's probably going to be a directly proportional relationship. Okay, but we'll see. All right, so, and by the way, this data is a little bit old. Okay, so it's 2016. So, you know, these guys may not exist anymore in the NFL. Hopefully they exist. All right, so we're going to do a number of things with this. Okay, so hopefully you guys have this pulled up somewhere. Okay, because I'm going to flip back and forth between the white screen and this. Okay, so first thing we have to do, we have to define what the explanatory variable is as well as the response variable. All right, so in this one, I think it's pretty clear. We've done this a number of times. All right, but the explanatory variable is going to be the height. All right, and guys, we know that because it's the first one, but we're using the height to explain the weight. Okay, so this is going to be the height. And this is going to be the weight for the response, okay?
Are they in centimeters for the height?
For the height, that's going to be in inches, okay? And it says it, I believe it says it, Helen, in the top. It's the height in inches, okay, yeah. So, yeah, so that's height in inches. And it's going to be the weight in pounds, not stones or kilograms or anything like that, okay? Now, of course, before we try to go through and determine the least squares line, we have to make sure that the data is fairly linear, okay? So what I'm going to do is I'm going to create a scatter plot for the data, okay? If it's not linear, then we don't do the problem, okay? If it is linear, that means we have to do the rest of it, okay? So, and I'm trying to move stuff around, sorry, guys. So just give me one moment while I move this stuff around. Okay, there we go. So for our scatter plot, okay, the x-axis is going to be the height, and we could probably go in increments of 1. Okay, so I'm going to start at 71 because that's the smallest height. We have 72, 73. It goes up to 77. All right, so 74, 75. If you want to do it in twos, that's fine too. Okay, so this is going to be our height, and that's in inches. Right, and then we have our weights. They range from 206 to 244. So let's start at 200, maybe go in increments of 10. Okay, so we have 200, 210, 220. All right, I know that's not a good marker there. Sorry, I know it's a little close to the other one, but you guys get the drift when we're doing this. 230, 240, 250. Okay, and this is going to be our weight, and that's in pounds. All right. And we're just going to plot these. Okay, so 77, 244, probably like somewhere up here. All right, right between. All right, it's really tough for me to draw dots. So if they look like cannonballs, sorry about that. 71, 206. Fortunately, that one's pretty easy. All right. And then we have our 76, 225. So somewhere like right about here, maybe. All right. And then finally, we have 75 to 14. All right, so we get it right about here as best as I can. All right. So here's our scatter plot. And I know I didn't ask for this, but let's just go ahead and define the scatter plot by strength, association, and direction. Okay, so strength, direction, and association. So you can either put it in the chat or you could just shout it out, guys. But what do you all think? Okay, take a minute, think about it. And if somebody wants to go ahead and weigh in what they feel the strength, direction, and association of this might be, go for it. All right, so what do you guys think, first of all? All right, strong strength. Okay, anybody else have a opinion? We don't get too many opinions in math. It's either right or wrong.
I think it's strong as well.
Okay. All right, I think it's strong as well. Okay. In fact, if I just covered up this dot right here, it would be almost a perfect straight line, wouldn't it, guys? It's just that one point that looks like it's making it slightly nonlinear. All right. For those of you guys that might have suffered through like pre-calc, exponential might not even be a bad relationship for it either. Okay, like if you were to draw like an exponential curve, but linear is probably best. Okay, so linear is going to be the association. Okay, easy one, direction, right, guys? Is this positive or negative? What do you guys think? Yeah, positive direction. Sure, good stuff, guys. Nice. You guys are all positive. It's positive. Ha ha ha. That's all I got this morning. All right. Good thing you all are mute. No groans. And then we said it was strength. It was going to be strong. Okay. So when we get our correlation coefficient, we're guessing that R should be what, guys? Like maybe like 0.9 or 0.8, somewhere like that, right, guys? If we got like a 0.1 or like a 0.3 or a negative 0.9 or something like that, that's bad. Okay. So the whole purpose of drawing the scatter plot is to kind of picture in your head what the correlation coefficient might be for this. All right. Now, of course, we're not going to do this by hand, right? We're going to use our calculators to be able to get the correlation coefficient and also the standard deviation and all that good stuff. Okay. So that's part C. Okay. And part C for us is going to use the calculator to get S sub X, S sub Y, X bar, Y bar, and R. Okay. All right. So I'm going to give everybody a moment just to go ahead in your calculators. And I'm assuming some of you guys are probably doing this while I've been talking, which is good, making good use of your time, not bad use of your time. But if a few people, once you get any of those, you can either put it in the chat or just shout it out loud what you got. Okay. But we need these to be able to find the least squares line. Okay. So take a moment, guys. And when you get something, like I said, either throw it in the chat or just let me know what you get. Am I getting anything yet, guys?
R, excuse me, R is 0.8567.
8567. Okay. Good.
That's if everybody got the same thing.
X bar 7475. Thank you, Lindsay. Okay. And then Y bar 22225. Thanks, Catherine. Thanks, Lindsay. 22225. It's a lot of twos. All right. So just need the standard deviations, friends. Oh, and just in case, I didn't explain how to get it, just to make sure everybody knows how to get it. Remember, you go stat on your calculator and then edit. Okay, and then in list 1, you're going to put the data. Okay, for list 1, and then list 2, you put the data. Then you go stat, calc, and then var stat. Almost ran out of room. By the way, thanks, Catherine. I see it that you put it in there. All right, good stuff. So var. Right, and then once that should give you the first 4 of those variables. And then finally, to get the last one, the R, stat calc, and then lin reg AX plus B. Okay, so we got SX 2.630. All right, and then we just need that SY, please.
XY, I got 16 point, basically 46. It's 4595.
Okay, 460. Okay. All right. Do all of those values look good to a few of you that went and did it in a calculator? Just want to make sure that nobody has any discrepancies about any of those. Okay, Jess looks good. All right. All right. Thanks, Lindsay. Nice. Okay. So I feel confident moving forward. Okay. If you guys need to know how to do this, okay, in your calculator, make sure you set up an appointment with me. Just hang out afterwards. Okay. I'd be happy to help you guys out. Okay. But obviously, if you can't get this step, then the rest of it's going to go downhill from there. All right, so now we're going to use the formulas, okay, to be able to compute the least squares line, okay? And let's see. So we're going to use these formulas. So B sub 1 is going to be equal to R SY over SX, okay? And then B sub 0 is going to be Y bar minus B sub 1 times X bar. Okay, so if we throw those into our calculators, okay, and we go ahead and compute, we know that R was 0.8567. We know that SY was 16.460. And we know that SX was 2.630. And so if somebody can go ahead and just let me know what they get from that, okay, that'd be most helpful. And if you could approximate it to 3 decimal places, that'd be helpful, guys. You could either just throw in the chat or just shout it out once you get it. I think if you guys can verify this, okay, I just used the crappy calculator. Yep, that's Lindsay, that's exactly what I got. Okay, Catherine, that's exactly what I got, 5.362. So we're either all right or all wrong. Okay, we'll go with all right. Okay, thanks, Jess. Thumbs up, good stuff. All right, now we need B0, okay, and to get B0, we just go through and plug in our B1. So remember, Y bar, we got 2.2 or 222.25. We're going to subtract from that the 5.362 that we just got. Okay, so remember that was what we got for B1. And then X bar is going to be our 7475.75. That's a 7 in English. Sorry, let me erase that. That's a crappy 7. All right. And while I'm erasing this and rewriting it, so my obsessive compulsive disorder doesn't get the better of me, if you guys can go ahead and approximate this to 3 decimal places as well, that would be trippy. All right, and I'll go ahead and do it in my calculator as well. Hopefully, maybe. Okay, so negative 178.537. All right, that looks pretty close just by estimating it. So I don't have anything better. So 178.537. Right. And just to verify, a few people got the same thing, thumbs up, thumbs down. Looks pretty close.
Mine was really close, but I got negative 178.560.
Okay, that's fine. Okay, like
Yeah.
5. You got the same thing.
That's what I got.
Okay, so it's 560. Okay, since a few more people got that, I'll just go with that. If you got 537, that's fine too, guys. Okay, so 5. What was it? 60, guys. What you got? Okay, that's fine. Okay, but Jess, your answer is perfectly fine with me. Oh, you didn't use the rounded numbers. Gotcha. Okay, so you just went and you did like the ants in your calculator. Okay, that's fine too, guys. Whichever way. Nice. Okay. So Jess, your answer is probably a little bit more precise, but since we're rounding to 3 decimal places, this is probably what more people got. Okay, yours is fine though, Jess, no problems. All right, so the equation of the line, this is going to be our slope. Okay, so this is our B1, And then this is going to be our y-intercept, which is b0. Remember, the equation for the least squares line is going to be y hat is going to be equal to, that's a terrible hat, there we go, b sub 1x plus b sub 0, which in this case, y hat is going to be equal to that 5.362 x minus the 178 point, I think it was 560, right, guys? Okay. So this is the equation of the least squares line. Now, remember, guys, you can check this, right, in your calculator. So in your calculators, guys, remember, if you go calc, I'm sorry, if you go stat, and then calc, and then lin reg, ax plus b, remember, that's going to spit out the a and the b values, okay? And a should be the slope, and b should be the y-intercept, okay? Or in this case, a is going to be b1, and b will be b0, okay? So make sure you guys use your calculators on the examination on the quiz to check, to make sure that you guys got the right answers. And if not, then you want to go back and compute stuff again, okay? All right, questions? Everybody good up to this point? Feel okay?
So the A and the B and the LinReg are just like it's for B1 it's 5.631.
Yeah.
So that's close enough.
Absolutely. Yeah. I mean, that's accurate to the hundredths place. That's really good. And
the B is negative 178.52.
okay, and that's fine too. Okay, we got 560, so that's accurate to the tenths place. Remember, guys,
Okay.
we're rounding off to the thousandths place, so there is going to be some rounding error on our precision. Okay, so that's perfectly fine. Yeah, those are solid answers to me. All right, guys, other questions, comments so far? Everybody feel good about that, or good enough? Well, you might not feel good about it. Let me rephrase that. Everybody feels like they can do it. That's the question I care about. I don't know if you like, I don't care if you like it or not. You got to do it, right? Okay. All right, guys. Next steps. Okay. We're going to go ahead and do some extrapolation and interpolation. All right. And our instructions tell us that we are supposed to use the equation of least squares line to predict the height of an NFL quarterback whose weight is 230. Okay. So this is part D. And so the weight equals 230. And which variable is the weight? Is that the x variable or the y variable, guys?
The y.
Indeed, right? Remember at the very beginning of the problem, okay, we went back and we said that the response variable, which is the y, was the weight, okay? So that's probably the way to think about it, is that the x is going to be the independent variable or the explanatory variable, and the y is going to be the response variable. All right, so that means that we're going to have to substitute for y hat the 230. Okay, so that's going to be our y hat. So that means 230 is going to be equal to our 5.362x minus 178.560. Right? And guys, this isn't one that we can just shove into the calculator. Okay, if it was the height, we could. Right? But what we're going to have to do is we're going to have to solve this like a regular linear equation. Okay, so, and you guys did this really nicely on Monday. Okay, so remember, what you guys are going to do is you're going to add the constant, in this case, not subtract, but add. You're really subtracting a negative. So we're going to add 178.560 to both sides. All right, so that's just going to give us what, guys? 408.560 equals 5.362x. And then finally, to get rid of the coefficient, we're going to divide. Okay. All right. And I'm going to go ahead and type this in my calculator. All right. So I got 408. But if somebody gets it before me, since I have to find my calculator, I don't know where it went. If you could throw it in the chat, that'd be helpful. So that way I don't have to type it in to this calculator that's on my screen. So 408, 560. Oh. Yeah, this thing doesn't like me. Because I'm typing a bunch of stuff. Helen, you got 79,195. Okay, good. All right, so that's going to be 79.195. Okay.
I'm sorry, I typed it in wrong. It's 76.195.
Okay, got it. Okay, thank you. So 76. Oh yeah, the 9 and the 6 key. I see what you did. Okay, got it. Okay. All right, everybody comfortable with that? Any questions about how to try to solve if given the dependent or the response variable for y? Okay, you basically just solve it like a linear equation. Okay. All right, guys. So the next question asks us, is this an interpolation or an extrapolation, and why? Okay, so to be able to determine if it's an interpolation or extrapolation, what we're going to do is we're going to go back to the original data set. Okay, and the original data set, hopefully it's showing up on your guys' screen. What you're going to do is you're going to look to see if 230 falls between two data points. Now notice that they're not in order. Okay. But I want you guys to notice that 230 is between this 225 and this 244, right? So if you guys were to put these points in order, okay, according to the y variable or even the x variable, what you would see is that 230 is between two of the values, 225 and 244, which makes it an interpolation. Okay, so the way I would answer this question is I would say, and this is part E, I believe, since y equals 230 is between, what were the two values, guys? I just lost them. It was 225 and 244, I think. Yeah, that's it. Thanks, guys. 225 and 244. This is an interpolation. All right. Okay, so any questions about how to determine if a prediction is an interpolation or an extrapolation? If it falls between two values that are given, interpolation. If it's after or before all of the observations, it's going to be an extrapolation. Okay. All right, guys. So now we have to move on to the residual stuff. Okay, so it says compute the residuals for each data point. Then we have to identify the closest and the furthest point. Construct the residual plot, and then determine if there's any outliers. Okay, so now you guys might remember to be able to compute the residuals. Okay, first thing you're going to do is you're going to find the y predicted or the y estimate. Okay, and to find that, what you guys are going to do is you're going to plug in every one of the original x values into the least squares line. Okay, so remember we got y was equal to 5.362. And the first x value that we had, I have to find it, I lost it. I think it was 77. I think that was the first one. All right, I lost it. It was 77. Okay. So 77 minus the 178 point, was it 260 or 36560? Okay. Then we're going to take 5.362 and we're going to plug in the second x value. Okay, and we're going to do the exact same thing. That's a 0, by the way, right here. And then we're going to do the same thing. I think the next one was 76. Let me verify that so I'm not lying to you all. It was 76 and then 75. Okay. So 76 minus 178.560. And then finally, the last one, 5.362 times 75 minus 178.560. All right. So, of course, I'm going to need your guys' help. Okay. So once you get any of the predicted values, if you would be so kind as to either put it in the chat, or you could just shout out what you get for it. All right. It's a little bit of pain to be able to do this. Sorry, I didn't make this stuff up. I just make you guys do it. All right, first one, 234,314. All right, thank you, Lindsay. Third one, Ben, 228.952. Thank you, sir. Excuse me, guys. So 234, 314, third one, 228. Wait.
I got something different.
Okay, for which one? The third one or
For the
the?
third one, yeah, I got 249.472.
Okay.
I got the same
Oh,
thing.
never mind. I did something wrong. Never mind. Ignore me.
Okay,
Yeah, I
so
got-
third one's good, guys. Okay, gotcha. Okay, thanks, guys. That's okay. All right. All right. And then anybody get either the second or the fourth one? Okay, Jess, 202.142. Thank you. And the last 223.59. All right. Thank you, Presidente. All right. Anybody get any discrepancies about any of those four? Okay, so thanks, Lindsay. Thanks, Ben. Thanks, Jess. All right, good stuff. Keeping us rolling here. All right. Now that we have the predicted values, now we can get the residual. Okay. And the residual, that should say residual. I don't know what that says. Now it kind of says it. Is going to be the y actual. Boy, not having a good day here with the whiteboard. So, all right. Y actual minus the y predicted. And the y actual comes from the original data. Okay, so our original data is going to be our 244, our 206, our 225, and our 214. Okay, so I'm just going to write those up here. So we have a 244 and our 206 and our 225 and our 214. And just to make sure everybody knows where to get the y actual, what you're going to do is you're just going to go back to the original data. Okay, I'm trying to bring it up so that way you guys can see, just so that way there's no questions about where to get it from. So let me go back. Okay, and hopefully the screen's sharing with you guys, but this is the y actual data. Okay, so if you have any questions, guys, about where to get the values, make sure you stay after so I can try to help you out with that. Okay, all right, so going back, the predicted values are the ones that we just found. So the 234.314, and then the 202.142 and 228.952. That one's pretty close. And then 223.59. All right. So folks, once again, I'm going to need y'all's help to be able to compute these residuals. All right, first one, Lindsay, you got it, 9.686. All right, thank you. Let's see, second one, I might be able to do these in my head, or not my head, but you know what I mean. So 3.858. This one's going to be a negative 3.952. All right, and the last one, gotcha. Thanks, Jess. Negative 9.590. Okay. That's a 9, not a 4 there. Okay. And can a few of you guys just check to make sure that I did the other two correctly? And I didn't do any mental errors or anything like that before we go on. Okay. And by the way, guys, remember, if you add these up, they should be equal to approximately 0, right? And it looks like it does. I mean, we can just do a quick inspection. We have a positive 9.6 and a negative 9.6 for the last one. So those look like they're pretty close to one another. And then a positive 3 and a negative 3, almost like positive and negative 4 almost. So they pretty much will cancel each other out. Okay, I know there's like a little bit of rounding in there, but okay. So we feel okay about these guys. Any questions about how to compute the residuals? Okay. All right, guys. So now that we have the residuals, okay, let's do something with them. The next question that we have to try to answer is we're going to try to find the point that's going to be closest to the line and then furthest from the line. Okay, so now remember what we do is we just take the absolute values. Okay, so we just ignore the signs and we look for the biggest number and the smallest number. Okay, and it's pretty tight, right? Because there's two numbers that are bigger than the other two, and there's two numbers that are smaller than the other two. But to me, it looks like that this is going to be the largest residual, right, guys? The biggest one. 9.6 is bigger than 9.5, okay? The one that's going to be smallest is going to be the 3.858, okay? So that's the smallest one, okay? Which means, now remember, the question was, which are the points that are closest and which are the points that are furthest, okay? So this just means that it's going to be the first point that's farthest, and this just means it's going to be the second point that's the shortest or the closest to the line, okay? Because we just go in order of the residual, okay? So if we went in order, this would be like the first, the second, the third, and the fourth residual, meaning that the first, second, third, and fourth points correspond. So the first point is going to be 77,244 is the point closest, or I'm sorry, furthest from the line, right, guys? Because that was the biggest one. Sorry about that. So is the point furthest. Okay, and then the point that's going to be closest is the second point. Okay, and just to make sure everybody knows where I'm getting this from, okay, what I'm doing is I'm just going back to the original data, and I'm just looking at the first ordered pair, which is 77,244. That's the furthest. 71,206 is the closest point, okay? So that means that points that are around that one are going to be more reliable than the points that are going to be around the 77,244, okay? So remember, guys, the whole point of doing the residuals is to kind of go for the errors for this stuff, okay? All right, so let me go back, finish that out. And we had 71,206 is the point closest. Okay, so again, just to make sure everybody understands that, what you guys do is you go back, you look at the residuals. Okay, you look for you take the absolute values, just ignore the signs, and then these are going to be the two that are closest and furthest. Okay, any questions about how to figure out which point is closest and which point is furthest from least squares line? Okay, all right, guys. Next thing we have to do, probably make the residual plot. Okay, so what we're going to do for the residual plot is we're just going to start by drawing something that looks like this. Okay, so get this. All right, now this is 0 all the time, right? And when we plot this, on the x-axis is going to be the residual name. Okay, so, and I think in class, did we use like R1, R2, R3, and R4, like the different residuals? Okay, some people use like E1, E2, E3, E4. I've seen that before to represent the errors. Okay, on the y-axis is going to be the actual residual. Okay, now we have to remember that the range for this, okay, so if we go back, the biggest residual we have is 9.6. The smallest we have is negative 9.5. So it might be beneficial for us to go in increments of like 2s or 5s, all right, on our axes, okay, to make sure that we encapsulate all the responses. I'm just going to go in 5s because I'm lazy. All right, so this is -5 and this is -10, okay? And remember, guys, we got like 9.6 for residual 1. Okay, so what I'm doing is I'm just plotting these like a scatter plot. So we have 9.686 for the first residual. So that's going to be like right about here, just below that 10. And then the next one we had was 3.858. So just a little bit under the 5. Okay, so maybe right about here, as best as I can. And then we get positive or negative 3.952. Okay, so maybe right about here, as best as I can, guys. And then finally, we have like negative 9.6, I think it was about. So just a little bit above that -10. All right. Boy, our residual plot looks like a perfect line, doesn't it, guys? And that's not by chance. I mean, that's just completely by chance. Okay. It doesn't always work. I think the one that we got in class, guys, it was kind of like up, down, all over the place. Okay. If we were to reorder the residuals or the points, we would get a completely different looking residual plot. So we're not looking for it to be linear or strong or negative or anything like that. we're really looking for the distance from 0. Okay. All right. Everybody good with being able to create the residual plot? Okay. Any questions about that? I know we did it at the end of class on Monday, so we might have been getting tired by that point. So just want to make sure we have another example. All right, guys. Whole purpose of the residual plot to look for suspect outliers. Okay. If I look at this graph, or if you guys look at this graph, because you guys are going to be the ones that have to do this, what do you guys think? Take a minute and think. Do you think that there's any outliers? Do you think that there's anything weird going on here with the data, or do you think it's pretty normal, like there aren't really any suspect observations? So take a minute, think about it, look at it, and then I'll ask a few people if they want to provide their opinions. Jess, you say no outliers, okay? Anybody else have any thoughts? I know a thought I have. I'm hungry. Okay. Yeah, I mean, there's a couple ways to think about this. All right. We're looking at these 2 points, right, guys? The ones that are furthest from 0. All right. Some people might consider those outliers because they're fairly far away from the other 2, but they're reasonably close in distance from 0, right, guys, to each other. Okay, so like if we drew a line to 0, like this line and this line are about the same length. All right. The other thing is, guys, we've only got 4 observations. So what's really an outlier with 4 observations? Okay. Now, I know on Monday we had a point that was pretty far away from the rest, right, guys? That was a pretty obvious suspect observation. Okay. So there's 2 ways to answer this correctly. Okay. Personally, I don't think that there's any outliers. Okay. That's just my interpretation because the 2 points that are furthest are almost equally as far. Okay. So 2 possible answers could be no outliers. Okay. Or point 1 and point 4 may be suspect. Okay. Since they're furthest. Okay, so I would accept either of those 2 answers. Okay, and realistically, guys, I know you've only created 2 residual plots in your life. Okay, so we're not all experts at doing this. Okay, so, but realistically, guys, what's the point of creating the residual plot? To look for suspect observations. And what will we do with those suspect observations? Well, we look and see why they occurred. All right, so they may have occurred just because natural reasons, okay, that's just their real height and weight, or maybe Cam Newton stepped on a scale after he ate too many nachos one day, okay, and it threw off the scale, okay, which means that the residual plot's off, okay. Realistically, guys, they're not really outliers, okay, but I would accept either answer, okay. All right, so let's go back and make sure that there's no questions about anything that we did today, okay. So we did a lot of stuff, okay, so everybody's good with response and explanatory. We've done that many, many times, okay? Everybody's good with scatter plots, right, guys? We've done those many, many times, okay? But questions I want to make sure of, okay? Any questions about how to get these 5 variables from your calculator? Any questions about how to get the equation of the least squares line, okay? How to get B1 or B0, okay? Any questions about interpolations or extrapolations, okay, which we just did an extrapolation or interpolation, excuse me. And then any questions about any of the residual stuff. Okay, so now's your opportunity to ask any questions you might have. All right. Okay, guys. Obviously, if you have any questions, you can just stick around after we're done. Okay, or you could just set up an appointment with me and I can try to work through things with you. All right, so that's all the stuff that we needed to go through with residuals, and that's going to be the last stuff that's on both quiz 3 and exam 3. So given that, what I'd like to do is just take a minute to look at both of those as well. Okay, so let's take a look, and I'm going to go into Blackboard and not discrete math. You guys don't want that, trust me, that's painful. Let's see. So let's go down to the quizzes. All right, and I'm going to open up quiz number 3. All right, just to make sure that we didn't miss anything. And then if you guys have questions, I can certainly answer those. All right, so give me a sec, and then I'm going to do the same thing with the examination. All right, and let me make this a little bit larger so that way everybody can see it. Okay, so what you'll notice is the problem that we just worked through. Okay, so now we have a little bit smaller numbers, but we also have 5 instead of 4. Okay, but we just did explanatory response. We definitely did scatter plot. We just did SX, SY, all that good stuff. We did the equation of least squares line, extrapolation, interpolation, residuals, point closest, point furthest, residual plot. It's almost like that problem we just did is the exact same thing as the quiz. In fact, I think I took the instructions word for word and just copied and pasted them and changed the scenarios here. Okay, so everybody feel that they're adequately prepared to do the quiz stuff. Any questions I can answer about anything that's on this quiz? Okay, so Mariama, you got that the sum of your residual did not equal 0. And oh, I'm sorry, and Mindy, I just saw yours. Mindy, let me answer yours first because you asked it first. Would I be finding what X is for the quiz? Okay, so you're trying to predict the heart rate before the walk if the heart rate after the walk is going to be 120. So what you're doing is you are finding what X is. You're correct. So 120 is going to be Y because that's going to be the rate after the walk. So you're absolutely right, Mindy. Good stuff. Okay. Now, Mariama, you got that the sum of your residual did not equal 0. And that was on the quiz, correct, Pam? Just want to make sure, not on the stuff we just did. Yes. Okay. How far were you from 0? Was it pretty far or was it kind of close to 0? Because it might just be rounding error. Let me rephrase that. It might just be due to rounding. Okay. Miriam, if you can send me a picture of your work, okay, that way, because quite honestly, I haven't done the solutions yet to this. And what I'll do is I'll compare it with my work, and I'll let you know by end of day if there's a significant difference or it's just rounding error. Okay. And by the way, if anybody else wants to do that, if they get an error and they just want to send me a picture of their work, I'd be more than happy to look over anything you want. Oh, you're quite welcome, ma'am. My pleasure to help you out. Okay. All right. Any other questions about the quiz that I can answer for folks? Okay. All right, guys. Again, hang out if you have any questions. I'm happy to answer whatever I can. All right. Exam stuff. Okay. So let me go ahead. Let me close this. Close this because we don't need it anymore. All right. The exam is under announcements. Okay. And I'm going to actually bring this one to the top. Okay. So let me scroll this all the way up so that way you guys can have it. So it should be now the first announcement. Okay. And it's right here. Okay. So I'm just going to click on it. All right. And it might take a minute to open. I haven't opened any PDFs today. Okay. There we go. All right. So just making sure that everybody understands where to go to get it. Instructions are at the top. Okay. Make sure you guys show me all your work things. Okay. So just like the quizzes. Okay. So basically it's just a big quiz. Okay. That's worth a lot more points. It's only your future. Don't sweat it. Okay. Yeah. So the first part, just answer them in complete sentences. If you guys want, you could just type it up in a Word doc. Okay. And print it out. Or you could just write it. Okay. I really don't care. Nobody in the class is as bad at handwriting as I do. I've been able to read everybody's stuff thus far. Okay. So, and I'm hoping that you guys have taken a look at the exam at least. Okay. Up to this point. So that way you can ask me some questions. But the first part is just literally the short answer questions. Okay. A lot of the same stuff that we've been doing in class. You can use your notes. You can go through anything you want to answer these questions. Okay. You just can't use any other people. All right. And then the rest of the stuff, okay, this is just problems that we've done in class. Okay, so this one's the categorical data that we did on the first day or the first or second day of class. I think it was the first day. This is the quantitative data where you have to use Sturge's rule. We did that on the second day of class. This is your mean, median, mode stuff, standard deviation. Okay, down here, this is the grouped data. Okay, so that's where you're using those formulas with the sum of MF. Okay, and then the other one, like your sum of M square F. All right, so make sure you guys are using the right formulas for this because it's group data. All right, and then the last two questions, this one's the correlation coefficient. Okay, this was the last problem on the previous quiz that you guys just got back. Many of you guys did really well with that. Okay, and then the last question is exactly what we just did with the football players' heights and weights. Okay, So can I answer any questions for anybody, either about the format of the exam or anything with respect to the examination or any of the problems with the exam? And I'm suspecting maybe some of you guys have looked at it, you just haven't done it because it's not due
No, I
to.
haven't done it yet, but if, can we email you if we have questions later?
Absolutely. Yep. And I might say something, I might guide you in the right direction. I might not give you the answer. Okay. Because obviously it's.
I don't want an answer. I just want guidance.
Oh, I want answers all the time. So, no, I hear what you're saying though. Yeah, I'm absolutely happy to give guidance to you guys. Okay. Like for instance, the question that Mindy asked earlier about would I be solving for the X variable? Absolutely. She didn't ask me what's the answer. She just asked me, am I on the right track? I'm happy to provide you guys with guidance for it. Okay. All right, guys. So any other questions I can answer about exam stuff? Okay. All right, guys. You guys know by now, email me, tie 2 cans to a string. Okay. Stalk me at my house. Okay. I'm happy to answer any questions you guys have. Good thing that's not being recorded, right? All right. So I'm going to stop recording at this point. So